In our beginner's guide, we looked at how straightforward railways can be when you start from the basics. Now it's time to build upon those foundations and seamlessly connect all of those different towns and industries together. We're going to move beyond those simple point-to-point routes and learn how to manage directional flow, branch lines, and high-capacity stations to create a true railway network. Hello there, Master Hellish here, and welcome to my intermediate guide to railways in OpenTTD. This tutorial builds on top of my beginner's tutorial, so if you haven't seen that, I highly recommend you check it out. The first thing we're going to look at is creating directional flow. We're going to use one-way path signals to enforce a direction of travel, and actually we've already seen this before. Here we have a path in place in our point-to-point station system, and you can see here we have a one-way path signal forcing the direction of flow down one side of the passing place, and another one-way signal forcing the direction of flow down the other side of the passing place. You can tell they're one-way because they've got the little red sign on the back. So what if instead of having a passing place where trains go one way down one side and the other way down the other, we just did that down the entire line? Well, that's exactly what we're going to do. Another way of thinking about it is we could take our loop line and squash it down. Let's do an example. We'll put a station here in at this town, and instead of looping out and all the way around to the other station, we'll turn around and join up with the track that's coming in. This will be one end of our loop. Then at the other station, we'll do the same sort of thing. Again, turning round, and we'll have the other end of our loop. Now we just need to connect these together. Remember, building across farmland in the early game can be very expensive for your company, so you might want to try and avoid it. And just like before, we will need some depots and some one-way path signals along the line. I'll get a train or three to go between the two stations, and off they go. So what we've created here is essentially exactly what we had last time in the terms of a loop. The only difference is, instead of it going between two stations in a big circle, we've kind of squashed that circle down. This is the basic fundamentals of having up and down tracks. Having up and down tracks in your network is a very efficient way to get your trains to go from place A to place B. Having a dedicated track for trains to go one way and then another dedicated track for trains to go the other means lots of trains can get up and down your lines without having to wait for each other. Before we can advance this one step further, we need to talk about stations and the types of stations. These stations are Ro-Ro stations. You can come in one side and out the other. And these ones down here are Terminus stations. The train comes in, stops, and terminates at the station, usually then turning around and going back the other way. Ro-Ro stations are fine for industries. They have really good throughput, and you only need a bit of the coverage to cover the industry in order to get what you need either going in or out of your station. The rest doesn't really matter. This is different to towns and cities, where you want to get as many buildings in your coverage as possible. You tend to avoid Ro-Ro stations as they take up extra track going in or out the back of the station, and terminus stations become better for cities and towns. A good terminus station can be almost as good as a Ro-Ro station in terms of throughput. If you want to see more about station designs, check out my dedicated tutorial, Stations Designs and Their Signals. So ideally these need to be terminus stations. Let's convert them. I'm going to start by cutting off the track. Doing this makes sure that no trains are going to come into this area while I'm redeveloping it, and we don't end up with any accidents. I'm going to take away the track either side of the station by using remove mode. I activated it with R, or you can press the bulldozer icon. Because I'm turning this into a terminus station, I can actually afford to fit this even closer into the town, and I'm also going to make it 2 tracks, to give us more space for more trains to wait in the station. The question is now, how do we connect this up? Well, it's actually quite straightforward. We want a piece of track going into each platform. We want a piece of track going down the up line and a piece of track going down the down line. And then, so that trains can use either platform and then get back the other way, we then put a little bit of cross track in there. Add some signals, and then we reconnect the line so the trains can carry on. You can see here that as the train is approaching the station, the signals turned green because there is now space ahead of it for the train to go forward. Once the train goes past the signal, we can see that the train has reserved one of the platforms in its path reservation. We can see as the second train approaches the signal, it's currently red because there's a train in the block ahead of it, and the train approaching has only allocated the path up to the signal. When the second train reaches the signal, it will check to see if it can get a valid path, reserve it, and continue. There we go, we had a path reservation into the second platform. For a terminus station, you don't need signals on the end of your platform. We sometimes say it's like the station has a signal at the end of its platform, but really what's happening is anytime a train turns around, it will always wait to try and reserve a path, whether it's at a signal or not. So when our trains turn around in our station, they will each exit one at a time down the opposite line it came in on. The first train going, and then as the second trains just turn around, it'll wait until it can reserve a path, and as soon as it can reserve a path, it will head on down the line. I've just upgraded the station at the other end as well now. These little crossovers here are a primitive form of junction. Anywhere where the tracks diverge, merge, or cross over each other are a type of junction in OpenTTD. One of the great things about having up and down lines like this is you can have multiple up and down lines and you can connect them together. Let's look at another example. Here we've got a 4-track terminus and the 2 lines come in and out. And all we need to do is make sure that each platform is connected to both the out track and each platform is connected to the in track. If we make sure that this is the case, then we have enough of a junction in front of the station for all trains going in and out to be able to access all of the platforms. This may not be the most efficient, but I've kept it simple for this tutorial. And whilst we converted our basic Ro-Ro stations into terminus for the towns, this is one way I would do a Ro-Ro station for an industry. I'm going to have 3 tracks next to this iron ore mine to make sure that I can come and pick up all the stuff. Then I'll have a turn afterwards, it's quite a sharp one, but never mind, and then we'll get the tracks coming out the other side. Now because this is not a terminus station, we need to make sure that there is a signal on the end of each platform pointing inwards. If you don't do this, incoming trains will see the entire station as one block, and they won't be able to reserve separate platforms as separate paths, because of the join after the station. Putting these signals in here separates the station from the merging track and allows trains to reserve a path into each platform. Here you see we've got one signal before the split going into the platforms, signals on the end of each one, and then you can have signals going up and down your line. And there we go. A slightly more complicated Ro-Ro station example for an industry. So we've looked at up and down lines, and we've looked at terminus and Ro-Ro stations, both simple ones and slightly more complicated ones. Now, how do we join these up with junctions? Let's connect this particular station down here up to the network above it. I've extended the line from our station out towards where I want to join it. What we can do is just bring the tracks together and go down the same sort of flow as previous. As there's trains running on this line, I again will disconnect the tracks to make it safe for us to play around with it. I will also remove the signals that are in the way. And then it's just a matter of making sure that each train can get to each location. So, trains coming in from the right need to be able to come down this line. I'll connect that up. Trains from the branch line needs to be able to come in both turning left and turning right. And trains coming from down here need to be able to come up and turn right there. This is one of the most simplest sorts of junctions you can do on these sorts of tracks. As always, we'll add a signal as we go into a junction, and then leave a gap of at least a train length after the junction before the next signal. I'll show you why we do this. I've deleted a piece of track to represent the path ahead being busy. You can see the train has stopped at the signal at the exit of the junction, and you can see that the train is partially blocking the junction. This is bad. We don't want our trains blocking the junction. We want them to enter the junction and flow through, or not enter the junction at all. This is why we don't have signals on the exits of our junctions, and we allow the trains to move all the way through. This sort of connection, where each track connects to each track where needed, is a good way to get started with junctions in OpenTTD, but they can be a little inefficient if the lines are quite busy. You can often get trains waiting for each other as they cross each other's path. The best way to deal with that is to not have the tracks cross each other at all. To simplify this slightly, let's say that we don't actually want to turn left here if we're coming off the branch line, and we only wanted to go between Halfing Way and Selborough Woods. One of the things we can do for this junction is smooth out this diagonal. There just happens to be a natural point here where it can merge off. Having larger diagonals in your junctions mean that trains don't turn so sharply and have less chance of slowing down. And then we're left with this crossover. Ideally, we want to get rid of that. One thing we can do is take out a section of track. lower the land, and add a tunnel. Adding a tunnel allows us to reconfigure this connection so that trains can come in and across without the lines actually crossing over. Then we can add our signals back in, and now we've got exactly the same turn off the main line onto the branch line, but now none of the lines cross. You of course could use a bridge here if you wanted to. Sometimes tunnels and bridges are personal preference. Tunnels do have an acceleration penalty, but it is quite small, and bridges have speed limits and sometimes can be a pain to upgrade, so I prefer tunnels. And that is the basic principle of all junctions, allowing all the trains to go in all the directions that they need to, ideally without crossing paths. Now it might look a little complicated, but I'm going to use exactly the same principles here to create another junction. We have lines splitting off each other in the directions they need to go, and one's coming in without crossing paths. So here we can have trains coming in from up north and joining the line that leads from our ore mine. Let's use the same principles here to connect this railroad station at this sawmill to this main line here on the goods network. First thing I'm going to do is connect the exit of the railroad station onto the line, make sure we've got signals going into that merge, and then ideally what we want is for this track to come down here and connect up onto the track. But we can't do that, the lines will cross. And we can remove a little bit of the track, pop a bridge or tunnel in, and then the lines split without crossing. And there we go. Simple connections, simple junctions, and it will work nice and smoothly. So you can see, with some basic principles, we've managed to make tracks that merge, connect, join, and separate, and without crossing the tracks, manage to keep a nice flow on the network. To increase the complexity, it's then just a matter of connecting more and more of these stations and junctions onto your lines. To learn more about my junctions, including more complex ones with multiple trains connecting from multiple directions, you may want to check out my junction designs and their signals video. So far in this tutorial, I've just been putting depots on the track like this, but it's not really the most efficient way to do it. Every now and then a train will need to come and service, and as a train goes into a depot, it slows down to a much slower speed, also whilst it's exiting. For this reason, it's best to put your depots off the main line. Over here in our little freight network, let's upgrade these depots so that they're off the line. I'll remove one of them, and then the first thing we need to do is get a piece of track to come off the line. We'll put a signal before the split, and then you want to have a run off the line longer than the train length. This allows the train to get off the main line fully before it turns into the depot and starts slowing down. Now there is a maximum length that a train will search for a depot off a line, so do not go more than about 14 or 15 tiles, even if your trains are longer. After that, you can pop your depot in, and then do another length and connect back onto the line. For signals, you again want signals before the merge, and a signal before the split. Now trains that need to service, like this wood train here, will come off the main line and then into the depot before servicing. It'll then leave the depot and head on back down the line. We can then implement this on the other side of the track, and this is a good start for better depots. Now whilst one depot is good, double depots are even better, like this. The reason why we use double depots is that one train can exit one depot whilst another train is entering the other. You can see here this is exactly what we've got going on here. Having this just increases the amount of possible throughput through the depots. So how can we improve these depots to have double depots? Well, one thing we could do is we could make the line stick out a little bit more. Doing so would give us enough space to put depots in like this, which would allow for an off-the-line double depot on either side of the track. To make sure trains don't use the depot line to try and get around other trains and cause problems, we often remove the bit of track flowing past the depots. This means that any train going onto the sideline is forced into the depot. Trains will not pass through these depots if there's an option to go the other way, so only trains that need to service will come off the line and use the depots. One further note on depots: don't put them directly after a junction. This could mean that a train wanting to service could choose the wrong track when it's deciding where to turn at a junction because it wants to go and service at the depot. If you want to put depots near junctions, make sure your depots are before the junctions rather than after. and leave a good 16 or 17 tiles after the junction before you place your depots. If you want to know more about servicing your trains, using depots, and more advanced depot placement, you can check out the How to Deal with Breakdowns tutorial video. I've mentioned train lengths a few times, but I haven't really gone into detail about how long your train should be. I've said here that you should have a train length long enough for the train to get off the main line before it goes into your depot. And last time I also said that your trains shouldn't be longer than your platforms because there's a penalty in the loading speed if your train is longer. But how long should you have your trains? Well, there's a large number of factors that go into choosing the length of your trains, and in some ways it's also personal preference. But here are my main two pieces of advice. Choose a train length for particular parts of your network and stick with it. That way you don't have different length trains trying to fit in different length stations. Say this entire passenger network is going to be length 7 or length 6. If you decide that, then you reduce the chances of having different length trains and causing yourself problems later. And the second piece of advice is you may want to choose a train length for your main lines between all your big places, but then smaller train lengths for feeder stations, little lines that are coming from smaller places that feed into your main stations. Remember, there's advanced game options to choose both the maximum spread of a station and the maximum length of trains. My personal preference is to have mainline trains somewhere in the region of 10 to 12 tiles long, and smaller feeder trains somewhere in the region of 4 to 5. Now, throughout the tutorial you may have seen me placing signals on track. You may have also seen me dragging signals on track. Doing a drag down the track places multiple signals in that drag section with a signal spacing which is set in your signal selection window. You can have these further apart or really close together. One of the best tricks when placing signals is to click, hold and drag, but also hold control. What this does is places your signals in a spacing all the way down the line, not just as far as you drag, but all the way down to the next depot, down to the next junction, or down to the next station. It doesn't place them after them. But this can help on really long lines placing loads of signals very quickly. You can also do this in the other direction down the line as well, and the direction that the signal is facing will dictate the direction of all the signals down the line. Clicking and dragging whilst holding control is a brilliant way of doing your signals on your network nice and quickly. Oh, and as well as adding them down the track, you can go into the signal remove mode and remove them all the way down the track by holding control as well. But you now may be thinking, how far apart should I have my signals from each other? Well, there are two aspects to this. The first is aesthetic. If you have your signals too close together, you may decide that it looks silly, and then want to choose to have your signals further apart, maybe 3 or 4 tiles. The other factor is throughput. Signals that are closer together allow trains to travel closer to each other, as we've got set up in this demonstration here. The trains are coming out the depot at the same time and going down the line at the same time. But the trains behind them will be able to come out the depots quicker and actually travel down the line closer to each other because the signals are closer to each other. This will give you more trains down the same line if your signals are closer together. So it's a balancing act between throughput and what you visually like to see. Personally, I have my signals every 2 to 4 spaces. Also, when it comes to signals, there is a particular setting of interest. Let's say I want to add a line here. There's a signal in the way on this piece of track. If I do it on a piece of track which doesn't have a signal on it, I can place the track. However, if I was to try and do it where the signal is, the game would say I can't, there's a signal in the way. But I've changed a game setting and you can see it on the screen now. If you change this setting, it will allow you to place track on a line where a signal is, and it will automatically remove the signal. I find this really handy. You just have to be careful that you're not going to cause a train crash. Removing signals could make that happen. We're now really starting to integrate our networks, and as you're doing so, something you might want to do is feeder stations. Now, there's a more advanced type which we'll look at in another video, but what we could do is have a basic station here at this iron ore mine. And what we could do is have these trains pick up the iron ore here, and instead of taking it all the way across to our steel mill, now there's a lot of river in the way, what we could do is transfer it at an existing place. I'm going to add an extra station in, and I'm going to hold control. Doing so brings up the join station window. What we can see here is a list of other stations that we could join this new station to. If your stations are close enough together, you can choose the one you want to connect it to, and now both these sets of platforms are the same station. If I connect it up as a simple row, and then join the tracks, we can then do our signals all the way down the line using our holding control method. Yes, they've gone all the way. This is actually a good way to check to make sure you've done your line properly, because if you get to the other end and the signals are missing, then you might have missed a bit of track or have a junction where you didn't expect it. And what we can do is tell our trains that after they've done their full load, they need to come down to this station over here, and at that station, transfer. They will come, drop off the iron ore, and it will get delivered to the station, at which point the trains that are on the main line will take the iron ore down to the steel mill. This sort of transfer service is really good for passing resources along a network, rather than trying to get 17 different tracks all joining at the same place. If you pass things along and transfer them, as long as you've got good lines and the throughput, it can actually be much better than trying to get all of the lines going to their one destination. So now you can see that not only by using transfer lines, creating junctions, both simple and slightly more complex, making sure we've got the depots, and the right signalling, you actually end up with quite a nice little interconnected network. No one part of this network is particularly complicated. We've got a relatively simple railroad station. We've got up and down lines. We've got some off-the-line depots. But putting it all together should warrant a nicely flowing interconnected network. When you're building your network, there is a particular order which I recommend for the best success. You may have noticed me do it already, you might not have. First, I do the stations. Doing the stations marks the start and ends of your lines, and you know where you're going to be travelling to. This includes the junctions and signals associated with your station. Then you connect all of your stations together with track, and then it's time for your junctions. Here I'm just going to use a bridge to make sure the tracks don't cross. Again, all I'm doing is making sure that each track can go in each direction it needs to, and making sure the lines don't cross. And then we just add our signals. Signals before splits. Signals before joins. Signals before joins. And signals before splits. And then we have a sort of T-junction. After we've added all the junctions, we can then do our depots. Here, instead of making the track further away from the main line, I've just added a hill and some tunnels so that I can make it more compact. And finally, we can add our trains. Do it in this order, with stations first, then their track, add in the junctions, then add in depots, and finally add in trains. Allows you to plan and prioritize the different parts of the network that fit together much more neatly and in the right priority. Once you've built your networks, you need to be able to upgrade both your tracks and your vehicles, and doing so is both rather easy. To upgrade your tracks, you just need to choose the type of railway you want to upgrade to. In this case, I'm going from standard railway to electrified railway, and use the Convert Upgrade tool. Swipe this across your network, and you can see in the area which you've swiped it, it will upgrade the tracks. If you want to do your entire world, you can go to the map, get a viewpoint, go to the top, and then go to the bottom in your screen. Going from the very top to the very bottom allows you to convert the entire network in one go. So it's all electrified now. And replacing vehicles is quite easy as well. You can go to the train window, down to the Manage section, and choose Replace Vehicles. On the left, you'll see a list of the vehicles that you have, and on the right, a number of vehicles you can change it to. I want to change all my steam trains to the Floss 47 diesel. I can choose the train, the Floss 47, and choose Start Replacing. Same with all the other steam engines. Then, the next time that they go to a depot, they will change into a diesel train, as long as you have enough money. If you don't have enough money, it will fail to renew the vehicle, and will try again the next time it goes in the depot. When it comes to trains, it's not just the engines that can be replaced. If you click this drop down arrow, you can also switch to upgrading wagons. Now, in the default game, this doesn't really matter much because there's only really one type of each wagon. But if you're playing with some mods or GRFs, then you may have different wagons and stuff that you can change throughout the years. One more note on upgrading your vehicles. If you're upgrading a train with a single engine to a train with maybe 2 engines like you see here, you can use the wagon removal tool. If you click it, it will turn it on. What this does is it will remove a wagon starting at the front of the train so that the train overall length doesn't change. This may seem like a brilliant feature, but a word of warning, there's nothing for the reverse. If you have a 2-length engine and you want to upgrade to a single-length engine, there's no wagon addition. Your trains will end up 1 wagon short. So personally, I never upgrade from a single to a double train if there's a chance that I will then upgrade to a single engine train later. For your next steps, I recommend the station designs and their signals, and junction designs and their signals. And after that, there's always the advanced railway tutorial as well. If you found this video useful, give it a like and share it with those people that you think will also benefit from the video. Check out the links on screen to those recommended tutorials, and leave all your thoughts, ideas and questions down in the comments below. Thanks for watching, happy railways, goodbye.